guys, I'm Hakan Kobir. This is my friend Junko from ADP. Today we are going to discuss about free fall and some problems that we have solved in our examples. We are also going to discuss on a specific problem on free fall. And thanks, Mr. Elvin, for giving us this opportunity to express and show our courage how to solve problems in class. And my friend here assisted me throughout the video and also supported me and guided me to find the solution. Thank you.
Now let me explain you about a brief history of freefall. The first idea of freefall was brought by an Italian scientist known as Galileo, which is the most famous one in Rome in 15th century. Then it is very easy to find the freefall in real life examples like skydiving, basketball, baseball, and dodgeball. So in next slide we will present about brief history.
All it glitters is gold, and she's buying the stairway.
Today we are going to solve this specific problem based on free fall. A stone thrown from the top of a building is given an initial velocity of 20 meters per second straight above. The stone launched 50 meters above the ground, and the stone just misses the edge of the roof on its way down. So there are like 4 sub questions based on this problem. Number A, T at position A equal to 0 as the stone is thrown from the thrower's hand at A position. Find time when it reaches maximum height. Question B, find the maximum height of the stone. And question C, determine the value of the stone when it returns to the point A. Question D is find the velocity of the stone when t equal to 5 seconds.
So basically, this is the diagram of the question what we have shown you before. The thrower at point A above the building, which is 50 meters tall, has thrown a stone high upwards. When it reaches B, which is its maximum point, its velocity becomes 0. That is, here final velocity here will be 0. Again, when it will be going downwards, that means when it will be free falling with the velocity of the earth, I mean 9.8, it will move at a constant speed, and when it will come to the point C, it will return to the same point where the stone was thrown. And if it continues more, it will still be going under the specific point D, which we will be explaining later. So the equations that are used to solve this problem is here. V equals to u plus at. Here V is final velocity, u is initial velocity, a is acceleration due to gravity, and t is time. And the second one is y equals to y naught plus ut plus half at square. Here y is the final distance, this is the initial distance. And the third one will be using v square equals to u square plus 2as.
The question, we are supposed to find the time taken when the ball thrown from the position A to position B, which is the maximum height. In the position A, the initial velocity is 20 meters per second, but at the maximum height in position B, the final velocity is 0 meters per second. And in this position, the object is against the acceleration due to gravity, so like the acceleration is minus 9.8 meters per second square. So we are supposed to calculate the time taken in between these two positions, which reach the maximum height. So we use the formula V equal to U plus at. V is the final velocity, and U is the initial velocity. A is the acceleration due to gravity. T is the one we need to calculate time taken between two positions. So like T equal to V minus U by A, which is final velocity minus initial velocity. So like minus 20, then minus 9.8. So like we got the velocity is
2.04.
time taken is 2.04 seconds. Yeah, this is the time taken to reach the maximum height at position B.
Okay, the second question is finding the maximum height of the stone when it reaches to point B. So here we will be using this equation. Here YB denotes the distance at the maximum point, that is at the point B. Y0 is the initial velocity where the stone is thrown, that is A, point A. And U is the initial velocity, T is time, and A is acceleration due to gravity. We all know that. So here YA is 0 because since this is the point where the stone was thrown from. U is the acceleration initial velocity which is 20. Time is the time we found from this one, which is 2.04 from the previous question. Half, negative 9.8 as explained earlier by my friend, and he just plot the values, and after doing calculations the answer will be 20.4 meters. So that's it.
According to the sub question C, we are supposed to find the velocity at position C, which jump down from the position B at maximum height. So like in this problem, we are going to use this formula. Vc square equal to UA square plus 2A YC minus YA. Vc square is the velocity at final position, which is at C. Then UA square is the velocity at position A, which is initial velocity. Then A is like acceleration due to gravity, minus 9.8 meter per square. Then YC is the displacement at C, position C, and YA is the displacement at position A. So we are going to use like this. Vc square equal to 20 square plus 2 9.8 then 0. So it's like supposed to be 400, and Vc square equal to 100, Vc equal to plus or minus 20 meter per s minus 1, but we are going to choose Vc equal to minus 20 meter per second because the stone is pointing to the downward, so that we are going to use like minus 20 meter per second as a velocity.
So the last question, which is question number D, is find the final velocity after 5 seconds and the distance that it covers after 5 seconds. So as we come here, we'll be using the formula V equals to U plus AT, same as we have shown the equations that we will be using. Here V is the velocity at point D, U is the initial velocity at A, and A is acceleration, T is time, that means 5 seconds. 20 plus negative 9.8 into 5. So after calculation, the value that we got is negative 29 meter per second. Another sub question was to find the distance of the stone when after 5 seconds. So we will be using the same equation here. Y equals to Y0 plus UT plus half AT square. Here Y will be the distance after 5 seconds, that means at point D. Here Y0 will be 0 since it's the initial point from where the stone was thrown, and U is the initial velocity as we have used here. So we just plot the values and let's find out what's the final calculation result. 25 plus half negative 9.8 5 whole square. So after calculation, the value that will be find is negative 22.5 meters.